You're standing in the middle of the Sahara Desert, the largest hot desert on Earth, nearly the size of the continental United States. The heat is suffocating. The sand stretches in every direction as far as your eyes can carry you. There is no water, there is no shade. There is, it seems, nothing at all, just an ancient, indifferent silence baking under a merciless sun. And yet, if you were to dig beneath your feet, if you were to brush aside that sand layer by layer and go back in time, you would not find more desert. You would find something so wildly improbable, so startling in its contradiction that it challenges everything your senses are telling you right now. You would find the bones of whales. Not fossilized fish, not ancient crocodiles, not even the scattered remains of some prehistoric watering hole, but the full skeletal remains of enormous ocean-going whales, buried in the heart of one of the driest places on Earth. This is not a myth. This is not a geological quirk. This is the story the Sahara has been trying to tell us for millions of years. A story about an ocean that vanished, a sea of green that bloomed and died, and what all of it might be warning us about right now. This is the Sahara, the ocean that became a desert. To understand how whale bones ended up in the sand, we need to travel back roughly 50 to 100 million years to a world that would be almost unrecognizable to modern eyes. The supercontinent of Pangaea had been breaking apart for millions of years, and in the process, it had created one of the most extraordinary bodies of water in Earth's history, the Tethys Sea. This vast, shallow, sunlit ocean stretched across what is today the Middle East, North Africa, and Southern Europe, covering the land that would eventually become the Sahara in hundreds of meters of warm, tropical seawater. And this was not a dead ocean. It was not a quiet ocean. It was an ecosystem of almost absurd biological richness, driven by the kind of evolutionary pressure that produces monsters. And it did produce monsters. Among the most spectacular was Paleophis colossius, a sea snake so large it stretched over 9 meters in length, gliding through those ancient shallows like a living ribbon of muscle and scale. Paleontologists working across North Africa have pulled its vertebrae from the rock in fragments that speak to a creature built entirely for dominance, a predator designed by millions of years of evolutionary trial and error in an ocean that rewarded size above almost everything else. And Paleophis was not alone in its ambitions. The fossil record from this period is riddled with examples of what scientists call gigantism, the tendency of ancient ocean ecosystems to produce creatures of almost implausible scale. Enormous catfish prowled the shallower margins of the seaway, filter-feeding sharks moved through the middle waters, and marine invertebrates built reef structures across the seafloor that rivaled anything alive today. But of all the animals that swam through the Tethys Sea, none have captured the scientific imagination quite like the ancient whales, and none have left a more dramatic monument to this lost ocean than those unearthed in a remote depression in the Egyptian desert, known today as Wadi al-Hitan, or as it is more poetically called, the Valley of the Whales. Wadi al-Hitan is a UNESCO World Heritage Site located about 150 kilometers southwest of Cairo, and walking through it is one of the strangest experiences geology has to offer humanity. Scattered across the desert floor, half swallowed by sand, are the fossilized remains of hundreds of ancient whales, creatures from a critical evolutionary window when whales had not yet fully committed to life in the sea. These animals, most belonging to genera like Basilosaurus and Dorodon, were transitional whales. They had the long, serpentine bodies built for swimming, the flippers shaped by water, and yet they also retained small, almost vestigial hind limbs, physical echoes of an ancestor that once walked on land. The discovery of these limbs was seismic for evolutionary biology, offering undeniable physical proof that whales evolved from land-dwelling mammals that gradually returned to the sea. But what Wadi al-Hitan tells us beyond evolutionary biology is equally extraordinary. It tells us that the ocean was here, that these whales did not travel to the Sahara, that they did not die on the shore of some nearby coast and wash inland. They lived here, they were born here, they hunted here. The sea was the Sahara, and the Sahara was the sea. So if an ocean once covered the Sahara, the obvious question is, where did it go? The answer lies in forces so slow and so vast that they are almost impossible to intuitively grasp, forces operating on timescales that make human history look like the blink of an eye. The answer is plate tectonics. The Earth's crust is not a single solid shell. It is a fractured mosaic of enormous rocky plates floating atop a semi-molten mantle, drifting in directions determined by convection currents deep within the planet itself. And roughly 50 to 40 million years ago, the African plate began its long, grinding collision with the Eurasian plate, a collision that continues almost imperceptibly to this day. As Africa pushed northward, the Tethys Sea had nowhere to go. It was caught between two converging continents, and it began to close, not dramatically, not suddenly, but with the relentless, irresistible patience of geology. The shallow margins drained first, exposing the seafloor to air and sky for the first time in tens of millions of years. Marine sediments became desert rock, reef structures became limestone cliffs. The bones of whales, once cushioned in ocean sediment, were sealed in stone and slowly buried beneath the wind-blown sand that would come later. What remained of the Tethys Sea was not nothing. It was reorganized, squeezed, and reshaped into the bodies of water we recognize today. The Mediterranean Sea is a direct descendant of the ancient Tethys, a remnant ocean caught between the same tectonic forces that drained its parent. The Black Sea, the Caspian Sea, and portions of the Persian Gulf also carry Tethys water in their geological DNA. But the vast central portion of that ancient ocean, the portion that covered what is today Algeria, Libya, Egypt, Niger, and Mali, that portion was simply erased. The land that rose from the sea floor was flat, mineral-rich from millions of years of marine sediment, and exposed to a sky that, for millions of years, would deliver significant rainfall. The desert did not arrive immediately after the ocean left. There was a long, complicated middle chapter to this story, a chapter that would have seemed to any observer alive at the time like paradise. Fast forward through millions of years of geological settling, past the slow oxidation of exposed seafloor, past the gradual accumulation of wind-blown sand, and land approximately 10,000 years ago, and what you find in the Sahara is not a desert at all. Scientists call this period the African humid period, and for those of us conditioned to think of the Sahara as an eternal wasteland, the evidence for it is genuinely disorienting. Lakes the size of modern European countries shimmered across the basin. Rivers ran through channels that are today nothing but dry, shadow-etched grooves in the rock, visible only from satellite. Forests and savanna grasslands extended across vast swaths of what is now sterile sand. Hippos wallowed in waters where today there is not a drop of moisture for hundreds of kilometers. Elephants, giraffes, crocodiles, and cattle moved across landscapes thick with grass and acacia, and humans, early human communities, thrived across the region, building cultures, herding animals, and leaving behind some of the most haunting artwork in the archaeological record. In the Tassili Niger Plateau in southern Algeria, and in a small cave tucked into the sandstone hills of what is today Sudan's Wadi Sura, ancient artists painted and carved images onto rock walls that now sit baking in hyper-arid desert. Images of swimmers, figures with rounded, floating limbs, suspended as though drifting through water, painted in ochre on a cave wall hundreds of miles from the nearest river. The site, known as the Cave of Swimmers, was made famous partly by the 1996 film The English Patient, but its true significance is scientific. It is direct evidence of human populations living, swimming, and thriving in a landscape that the modern eye would find unrecognizable. Elsewhere, across thousands of sites scattered through Algeria, Libya, Chad, and Niger, rock art depicts cattle herds, giraffes, elephants, and scenes of daily life that speak to communities utterly dependent on an environment of abundance. These were not people surviving on the margins. These were people at home. The Green Sahara was not an anomaly. It was the normal state of the region for thousands of years. Humid, fertile, connected by rivers and lakes, teeming with wildlife. And then, slowly and with devastating thoroughness, it ended. The death of the Green Sahara was not caused by a single catastrophe. No asteroid, no supervolcano, no sudden climatic rupture. It was caused by something far more subtle and, in many ways, far more chilling in its implications. A slow, rhythmic wobble in the way the Earth moves through space. In the early 20th century, a Serbian mathematician named Milenko Milenković worked out something that has since become a cornerstone of climate science, that the Earth's orbit and orientation in space are not fixed. They change over thousands and hundreds of thousands of years in three distinct ways. First, the shape of Earth's orbit around the Sun stretches and contracts over a cycle of roughly 100,000 years, a change in eccentricity that alters how much solar energy the planet receives at different points in the year. Second, the tilt of Earth's axis varies between about 22 and 24.5 degrees over a 41,000-year cycle, affecting how extreme the contrast between seasons becomes. And third, the Earth wobbles on its axis like a slowly spinning top, a phenomenon called axial precession that shifts which hemisphere is closest to the Sun during summer over a cycle of roughly 26,000 years. Taken together, these Milankovitch cycles act as a planetary thermostat and a rainfall regulator, subtly but relentlessly redistributing energy across the globe. About 10,000 years ago, the combination of these orbital rhythms put North Africa in a very favorable position. The summer sun was more intense in the northern hemisphere, which energized the West African monsoon and pulled massive amounts of moisture deep into the continent. The rains came, the lakes filled, and the Sahara turned green. But as the orbital geometry slowly shifted over millennia, that monsoon weakened, the rains retreated southward toward the equator, and without the moisture to sustain it, the vegetation that had stabilized the soil and reflected sunlight began to die. Here is where the story gets darker, because the loss of vegetation didn't just follow the drying, it accelerated it. When plants die and soil is exposed, the land becomes more reflective, bouncing more sunlight back into space and reducing local warming, which in turn further suppresses rainfall, a brutal feedback loop where drying breeds more drying. Scientists call this the vegetation albedo feedback, and in the Sahara, roughly 5,500 years ago, it appears to have triggered an abrupt and catastrophic collapse of the Green Sahara, a tipping point beyond which the desert rapidly expanded to cover the land that rivers and lakes had sustained for millennia. Within perhaps a few centuries, the lakes dried, the rivers ceased, the animals retreated or died, and the human communities that had called the Sahara home for thousands of years migrated east, many of them toward the Nile Valley, contributing, some researchers believe, to the population surge and cultural flowering that gave rise to ancient Egyptian civilization. The desert did not just kill a landscape, it may have redirected the course of human history. The Sahara is not a dead place. It is not a permanent fixture of the Earth's surface. It is a living clock, a landscape whose history is written in whale bones and painted caves and dried riverbeds, telling a story that spans hundreds of millions of years and touches nearly every force that shapes our planet. It has been an ocean floor, a tropical sea, a green savanna, and a desert, cycling through these identities in response to forces both planetary and orbital, some violent and sudden, some slow and rhythmic, and almost beautiful in their mathematics. And this history matters, not just as science, not just as geological poetry, but as a mirror. The same orbital mechanics that ended the Green Sahara are still operating. The same feedback loops between vegetation, albedo, and rainfall that collapsed a thriving ecosystem are still embedded in our climate system. Scientists today monitor the Sahel, the narrow band of semi-arid land along the Sahara's southern edge, as one of the most climate-sensitive regions on Earth, a place where small shifts in rainfall patterns can tip millions of people toward crisis. The Sahara teaches us that ecosystems which appear stable are often balanced on a knife's edge, that change can be gradual until suddenly it is not, and that the line between a living, breathing landscape and a vast and empty desert can be crossed faster than civilizations can adapt. The next time someone tells you the Earth's climate has always changed, that deserts and seas and ice ages are just the planet doing what it does, they're right. But the Sahara story also tells us just how radical those changes can be, how total, how final for the species and cultures caught inside them. We live on a restless planet. The sand remembers.